So, what have we done so far? Well, we know how to manipulate images in Pygame and display them to users. We know how to take user input and handle it. And now we're going to move on to our third and final major topic, basic animation. Let's get started. Pygame provides a whole variety of modules and methods for animating images. They range in complexity from simple to complex, and they have various functionality. So you're welcome to explore all of these on your own, but in this video we're going to focus on a simple approach to animation that's based on the tools we've already learned. I don't want to teach you a whole bunch of new functionality, so we're just going to use this approach. It's not necessarily the best approach, but it is a powerful and comprehensive approach to animation that I think will allow you to draw the animations that you'd like for whatever your project may be. If you want to do something really complicated, you might have to look up additional things, but I think this will be a good foundation. Let's begin with a little thought experiment. So I have a question, and I encourage you to actually pause the video and ponder this for a couple minutes, because I think it'll help you better understand what comes next. But our question is, how might we animate images using only the tools we've learned so far? One approach, and the approach that I think you would come up with if you actually thought about it, is the following. We're going to draw an image or shape, then erase it, adjust the position slightly, and draw it again. Now this might seem a little bit clunky, but if you think about it, it will accomplish what we want. We'll draw an image, and then animation is we want the image to move or appear to move, so we'll just erase it, we'll adjust the position, and then we'll draw it again. And if we do so quickly enough, this will resemble animation. So this is a perfectly logical approach, and we in fact could do this with just the tools we've learned, but unfortunately Pygame does not support this functionality. So Pygame instead is going to take a different approach that's a bit non-intuitive. Pygame's approach is to continuously overlay images on top of each other without ever erasing anything. So we can't just draw something, then erase it, and then draw it again. We have to just overlay things on top of each other. Which raises a couple of questions. First, why in the world would Pygame do this? Why can't it, include some functionality for erasing? And the answer to that is it's below our level of abstraction. It's below the abstraction barrier that we're working on top of. We don't have to worry about this. Maybe this is easier, maybe it's more efficient, maybe it's a custom, I don't know, you don't know, doesn't matter. The point is Pygame doesn't support erasing, so we have to figure out how to work with the tools Pygame does provide. Which of course raises a second question of how. And that's what we're going to spend the rest of our time investigating. If Pygame supported erasing, this video would probably be a bunch shorter and animation would be a lot easier. We would just use the approach above. But since it doesn't, we're going to have to get a bit creative. So let's look at what we can do. So we'll begin this journey with another thought experiment. And again, I encourage you to pause and actually consider this question. How might we animate images or drawings just by overlaying surfaces? Think about it. How can we do it using just the tools we have so far? Well, idea number one would be to blit the desired image onto the screen again with a slightly different position. So, okay, we have an image there, and we can't erase it, so maybe we just blit it onto the screen again. The way we get images onto a surface is blitting, and if we blit it in a different position, it'll look like it's moved. This seems like a good idea. However, this would leave a trail of overlapping images. We're not solving the problem of not being able to erase anything. We're just, continuously drawing the image in a new location, and that's not going to give us what we want. So this won't quite work. So then you might think, okay, well, maybe what I'll do is blit the image, or blit the image onto the screen, and then when I want to animate it, I'll just use the fill method to blank the screen. Remember we learned about the fill method earlier on and how we can just fill the screen with a black or any other color. And after I do that, then I'll just re-blit the image with a slightly different position. And so even though I'm not erasing, By filling, I give the user the illusion that I'm erasing the screen, and then I adjust the position, and then I draw the image again, and if I do this fast enough, it'll look like animation. So that seems like a pretty good idea, but this also has a problem. If we fill the screen, it'll cover all the images. What if we have, two people walking no, that doesn't work. What if we have two people and one of them staying in place and one of them's walking, and then I fill the screen? Then I'd have to redraw everything. What if I want to leave everything in place and just change the position of the person that's walking? That would be a lot less computational power and a lot less headaches on our part than erasing the entire screen and redrawing the entire screen every time. So idea number 2 maybe would work, but it's going to be annoying. We shouldn't use it. So we'll think again. Okay, when that disappears, we have idea number 3. And the idea here is we can store the position of the image using a rectangle. That's a feature of Pygame we haven't learned about yet. And then fill only the relevant portion of the screen. So instead of just covering the entire screen, maybe we can cover just a portion of the screen and then reblit the image. And that would allow us to change the position of the image and yet leave everything else in place. And in fact, this is the idea that we're going to use. This is what we're going to look at how to implement in code for the rest of this video. We're going to draw an image, we're going to store the position in a rectangle, we're going to fill only that portion of the screen, and then we're going to change the position and reblit. And when we do that fast enough, and as you know, computers work at lightning fast speeds, it will resemble animation. Rectangles. I mentioned this thing called a rectangle. What is it and how do I do it? Let's learn. A Pygame rectangle is an object, just like events or surfaces, and these are used to partition, track, and store information about particular portions of a surface. We learned about surfaces and how to manipulate surfaces. We also learned that surfaces are represented as a grid of pixels, and we can access particular pixels by their coordinates. But sometimes we might want to access an entire series of pixels, a particular portion of the surface. Not the entire thing, but not just a single pixel. And a rectangle allows us to do that. It's an object that tracks a particular portion of the surface and stores information for us. And if you didn't want that shape to be a rectangle, Pygame has other built-in objects that can store information in other shapes. But rectangle is the most common, and that's the one we'll talk about today. The way you initialize a rectangle in code is as follows. You use the pygame.rect function, rect stands for rectangle, and you pass in 4 arguments, x chord, y chord, width, and height, which we'll look at one by one. So the x coordinate is the x coordinate of the upper left corner of the rectangle. When you create a rectangle, we again use it to track a particular portion of a surface. And we need to tell Pygame where on the surface we want to track. So we'll give it the coordinate of the upper left corner because again, Pygame works in upper left corners, and that will be where the rectangle is initialized. We'll also give it the y coordinate of the upper left corner of where we want the rectangle to be. And then we'll have a width, because a rectangle is not just a single point, it has a width and a height, and the width is the x-axis horizontal distance, like I'm moving my mouse now, and so we'll give it a width, and then we'll give it a height. Again, that's the vertical y-axis distance. Width and height, I think, are intuitive. And when we have the x and y coordinates and the width and the height, then Pygame knows exactly where to put our rectangle. And then the output is a rectangle object corresponding to the desired portion of the surface. So you'll probably want to store the output of this method in a variable, just as we did with the functions we learned about in the images and displays section. You'll want to store the result of this in a variable so you can work with it later. Now there's a couple questions that probably arise when you're looking at this. First, does Pygame actually draw anything when it creates a rectangle? And the answer is no. This is not something that the user is going to see. If you want to, you could draw a portion of a surface and display it corresponding to the rectangle, but by default this is not going to draw anything or display anything. It's just going to create a rectangle. And then the second question is, well, which surface does this rectangle correspond to? You might have 10 surfaces in your game, and you create a rectangle, and which surface is this going to place it on? And the answer is, well, none of them. A rectangle is just a an object that has a particular location. And it's not located on a particular surface, but rather you could use a single rectangle to represent the same portion of different surfaces. So if we create a rectangle, if you follow my mouse, that starts up here at this bullet point, and then goes down here to this bullet point and goes across the screen, and so it fills this area that I'm tracing. That's not quite the entire amount of the screen. Pygame will not automatically place that on any surface. It'll just create a rectangle object that corresponds to those coordinates. Every surface has coordinates. So then if I want to manipulate surfaces, if I want to manipulate portions of surfaces, I can do that using this rectangle, because the rectangle stores a particular portion. And if you think about it, I think you'll realize that it's actually a good thing that Pygame doesn't bind rectangles to surfaces. Because if you have a bunch of surfaces and you want to do the same thing to all of them, it's best if you don't have to create separate rectangles for all of them that represent the same space. You can just create a few rectangles and use them on whatever surfaces you want. At this point, this is probably a bit abstract. You're thinking, okay, but what exactly do I do with a rectangle? So let's look at how we would actually use rectangles to do animation. Animation. Let's put this all together and actually animate something. At this point, you're probably thinking, wow, that's a lot of code and I'm scared. Don't be scared. We'll walk through it step by step. And actually, this isn't even all the code. I couldn't fit all the code on one slide, so there's 2 slides worth, but this is the first part, which is just going to initialize variables, surfaces, and rectangles. Here, we're just setting up our display. We're not actually animating anything yet. So let's walk through it. This first line is something that we already saw, and actually most of this is something that we already saw when learning about images and displays. It's just a review. So first we're going to initialize the display window. So we're going to call pygame.display.setMode with the desired dimensions and bind that to the variable screen. That's just going to set up the display. Then we're going to load this image onto a surface, this image called cool photo. I guess it's pretty cool. And we'll store that in the variable image surface. Great. Then I'm probably going to want to load the image onto the display. Right now the display surface and the image surface are separate. I'm probably going to want to blit the image surface onto the display surface. So I'm going to store the position where I want the image in a list. So this is a list containing the x coordinate and y coordinate of the upper left corner of where I want to put the image that I loaded onto the screen. Okay, this is very similar to what we did when writing our demo for the squirrel and the dog in the surfaces and images video. And now is when it'll become clear why I put these variables or why I put these numbers in a list. When I did that in the earlier video, you were probably like, why are you doing that? But I think it'll become clear now. So I put it in a list. And then I'm going to blit it onto the screen. And blit, again, takes the surface that I want to blit. This is the image. And the other argument is the coordinates of where I want the image to appear. Coordinates of the upper left corner. Well, I already put those in a list, so I just get the 0th and first element. It'll be 200, 200, and it'll put my cool photo onto the screen. This is all what we already know. And if all I wanted to do is display an image, I could stop here. But I don't just want to display an image, I want to animate it. So we're going to need to create a rectangle to track the position of this image. And we do that as follows. We call pygame.rect, which again takes 4 arguments. The x and y coordinates of the upper left corner of where we want the rectangle to be. And since we want the rectangle to just track the position of the image, we're going to give the same x and y coordinates as we did to the blit. So we'll do image position 0 and image position 1. And then, well, how wide and tall do we want this rectangle to be? I want the dimensions of the rectangle to exactly correspond to my image. I want this to completely overlay on my image so that I can track it perfectly. And so the width, I'm just going to call imageSurface.getWidth. This is a method we haven't seen before, but I think it's pretty intuitive and it takes no arguments. You just call it on any surface and it'll get the width of the surface. So if I call it on my image surface, it'll get the width. And then if I want the height, I call getHeight, and that width and height of the image become my arguments to this rect function, and then Pygame will output a rectangle that corresponds to this position. So it'll be, again, a rectangle that perfectly overlays with my image. And I'll store that in a variable. Then down here, I just update the display window, and now the user can see the image. They do not see the rectangle. That's just something internal for me as a programmer, so I can track this and animate it later. We initialized everything. Our screen is looking good, but we want to actually animate the images we put up. So that's what this code is going to do. Our goal here is going to be moving the image up by 10 pixels. That's all. Just a first shot at animation. And our process, as we described earlier, is going to be to fill the background. Then we're going to reblit the image in a new position, and then we have to update the rectangle so it still tracks. So walking through this line by line, this first line, screen.fill, is going to fill the screen in the desired location. Now we already saw screen.fill when we talked about surfaces, and this will look somewhat familiar. It'll just fill the screen with the desired color. But if I give it this second argument, it'll only fill a portion of the screen. So first I'll pass in the RGB value of the color I want to fill with. Here I did 0, 0, 0, so it'll be black as a tuple. And then if I want to fill only a portion of the screen or surface, I'll pass in a second argument, which is a rectangle. And so I already created this rectangle. It perfectly matches with my image. And by passing this rectangle in, I will only fill the image. I'll basically erase the image, but leave everything else on the screen, which is exactly what I want for animation. Then what I want to do, after the image is hidden from the user, is change the position of the y-coordinate by 10. I want to move it up 10. And here's where I think you'll start to understand why I stored the positions in a list. If I had just passed in, the prior slide, if I had just passed in 200, 200 here, okay, that would be fine, that would work, but then when I wanted to change the position, I would have to somehow retrieve what the prior position was. I didn't store it in any variables, so I'd have to somehow retrieve that and then change it and then pass it back in. And I'd have to do this every time I wanted to change the position, and if I was animating something all over the screen, that would be a lot of times. And that wouldn't be good. Maybe you could figure out a way to do it, but it would probably be a headache, and it's a much better idea to just store the position in a list of the x-coordinate and the y-coordinate, and then bind that to a variable. So now, when I want to actually change the position, I can just use that variable. I don't have to know what the position was. I don't have to know that it was previously at 200 or ask Pygame to retrieve that information for me. I just know that it was stored in the variable image position, and if I want the y-coordinate, that's image 1 of this image. That's item 1 of this list. So I retrieve the y-coordinate, and then I change it by 10, and it will update automatically in this list. Now, one question you should ask is, why do we subtract 10 instead of adding 10? Remember, I want to move the image up. This is not a bug. Remember that in Pygame, the y-axis starts at 0, 0 at the top of the screen and goes down and increases, the numbers increase as you go down. So if I want to move an image up, I actually subtract 10 from the current position. And that will move it closer to 0, 0, which is the top of the screen. Then, now I want to update the position of the rectangle. And I can do that easily using this moveIP function. So every rectangle you can call moveIP, so imageRectangle.moveIP stands for move in place. And I pass to it the amount I want to change the x position and the y position. So here I moved the actual image up 10, so I want to move the corresponding rectangle up 10. So I change the x position by nothing and the y position by negative 10. Then I've moved it. Now I can re-blit the image onto the surface. So I can just blit as we've done before. And I again can use the positions because I updated the positions over here when I updated that list. And then I update the display. Don't forget to do this, otherwise users won't see your changes. A very common bug with Pygame programs is forgetting to flip the display. And that's it. So that's how we can do some basic animation in Pygame. All right, now let's look let's go back to our dog squirrel simulation and look at a demo that actually implements some of this. So here we are. Here's the code as it stands. And to remind you of what this code does, fantastic. But we've got a ways to go if we want to simulate the real-world interactions between dogs and squirrels. And the first thing we have to do is make the dog move, because real-world dogs can move. So we need to animate this dog image that we put on the screen. And we'll do that using the techniques we just discussed. So up here, where I draw the initial images, I've already written all this code. I don't have to change it. The one thing I do have to do is create a rectangle that tracks the position of the dog image. I'm going to do that after after I blit the dog image onto the screen. So I'm going to do that. I'm going to store this in a variable called dogRectangle. I'm going to call pygame.rect as we saw, and the arguments here will be dog position 0. That's the x position. Again, I stored it in a list, and now you should understand why. And then dog position 1. That'll give me the y coordinate of where I want this rectangle to appear, and that'll correspond exactly to where the image appeared. So I'll pass those in, and then what should the width and the height be? Well, the width of this rectangle should be the exact width of the dog surface. So I'll call get width on that, and then the height should be the exact height, so I'll call get height. And there it is. This is the code. It's a bit long because we had to call these functions, but this is the code that will create a rectangle that exactly corresponds to the position of the dog image. Now I can track it. That's all I'm going to change up here in initializing everything. The actual animation I'm going to do down here in the game loop. And now you'll see how we can combine user input with the animation techniques we learned. So right now, the only user input we are tracking is quitting. The user wants to quit, we'll let them. But maybe we want the user to be able to control the dog. And when the user clicks the right key, the dog moves right. So we know enough tools now to where we can do that. So we checked whether the event type equals pygame.quit. Now let's add another condition. Let's say otherwise. If the event type is a key down event, the user puts a key down. Again, we can't check just for the right arrow. We have to say if any key has been put down. Then we can check which key was put down. So if the user pressed the right key, in Pygame that's called k_right, then I want to move the dog right. And to move the dog right, to give the user the illusion that the dog is moving, I have to animate the image, and that means we have to go through the process that we outlined a little bit earlier. So what I'll do is first call screen.fill, and I'll fill it. I'll just make it black because the background's black. You can do whatever color you want. And then I'll pass in dog rectangle, and that'll fill only the space corresponding to that rectangle. All right. Then I will update the position of the dog image, dog position 0 plus equals 10. Dog position 0, that'll give me the x coordinate, and then if I add 10, that'll move it 10 to the right. Then I've updated the position of the image. I want to update the rectangle, so I'll call dogRectangle.moveIP, and I'll pass in 10, 0, so I move it 10 in the x direction and 0 in the y direction. And then I'll blit this back onto the screen with the new position. I'll blit dog surface again, and the position will be dog position 0 and dog position item 1. Again, storing this information in a list is super useful. I don't have to know what position it was at before, And in fact, during the game, this is just going to execute over and over, and we don't want to keep track of where the dog is at all times. Through hard coding it, we can just store that in a variable and then access it and update the variable as we go. So there we have it, right? Actually wrong, we don't quite have it. We have one more thing we have to add, which we'll often forget to add, which is pygame.display.flip. We have to update the flip the display so users can see what we've done. And now we are done. Now we've written a program that can animate a dog. The user can press the right key and make the dog move. Let's see if this actually works. Exhilarating. So now we've written a program that is getting closer to modeling the real-world interactions between dogs and squirrels. I can make that dog chase the squirrel and apparently erase the squirrel and then run out into nowhere. Great. This is not exactly what we want, but this is pretty good. And now you know the tools to do this as well. So this is the last video that's going to go over content. In the next video, I'm just going to go through an extended demo where we'll further improve our game, and then we will have accomplished our goal using Pygame to model squirrel-dog interaction.